Okay, so how are we going to, add and subtract when the denominators are different? First, you got to find the LCD. Second, get LCD in each, we could say add in, but in each rational expression. Okay, so, and then 3, you have to multiply the numerators. I would say that's the sticky point for students. They're thinking they don't have to do that, and then that's going to be a problem. Then you're going to do the adding and subtracting. Add or subtract. And then you're going to simplify, if possible. Sometimes you can't simplify, but if possible. Okay, so those are kind of the steps. I think we've got a couple examples. So in this first one, you've got 1 over 3 plus 2 over x. So you're looking at the denominators. They each have their own factor. One has a factor of 3, one has a factor of x. So I'm going to rewrite the problem here, so it's a little bit bigger for me to work with. The LCD is going to contain a factor of 3 and a factor of x. 3x is the LCD. So what do I have to multiply by? Well, here I'm going to have to multiply by the x, because I don't have it, and here I'm going to have to multiply by the 3. It doesn't matter which side you write it on. Now, when I talked about multiplying the numerators, I've got to multiply that out. That's going to be x over 3x, plus this is going to be 6 over 3x. Now I can do the adding. I've got the denominators the same. I'm going to add those numerators, and so I have x plus 6 over 3x. Now, I've done it. Yay! I've added. I have one rational expression, one numerator, one denominator. The question is, can I simplify? Well, does the numerator factor? No. Okay. What are the factors in the denominator? You can put parentheses. That might help you see it. What are the factors in the denominator? 3 and x. Do I have a factor of 3 up here? No. Do I have a factor of x up here? No. So this is not going to simplify. I'm afraid students might be thinking, oh, I could cancel those x's, but you can't. It's x plus 6. It's not just a factor of x. And you can't cancel the 3 and the 6 because it's plus 6. It's not 6 times something. Okay? So I just want to go over that. All right, so here's another one. What's the LCD? Well, you might want to think about the factors here. 6 is 2 times 3, right? And then 9 is 3 times 3. And then you've got xx, or x squared. So what do I need in the LCD? Well, I'm going to have a 2. I'm going to have both of these 3's, because that's the most number of times it appears in one of the denominators. And I'm going to have both of those x's. So the LCD is going to be 18x squared. That's the LCD. Now let me rewrite it so I have a little more room. Now, what I think is kind of cool is I already broke it down into its factors up here. So I know what's missing. I've got a 2, I've got a 3, I've got an x, but I need another 3 and another x. So I'll be multiplying by 3x up here. Whatever I multiply in the numerator, I multiply in the denominator, or vice versa. Whatever I'm multiplying in the denominator, I also have to multiply in the numerator. All right, now let's look at the other one. I've got 2 3's and I've got 2 x's. So I've got all that stuff. I just don't have the 2. So I'll be multiplying by 2. Okay, now we want to multiply out the numerators. So I'm going to have a 15x over 9x squared minus, and I'm checking this to make sure that I did get the LCD, minus 8 over 18x squared. And now you're saying, I made a mistake, because it wasn't 9, it was 18. 3 times 6 is 18. Sorry about that. Okay, so yay, we got common denominators. What are we going to do with those numerators? It's 15x minus 8. I can't combine them, so I just write 15x minus 8. Now, can I simplify? Well, look at the numerator. Does it factor? No. There's no GCF, so that's all that would work in this case, but nothing goes into both 15 and 8. So we're done. Sometimes they do simplify, but not this time.